All right, so this lesson's going to take 2 days to do. This is very long. I do want you to graph a couple of these. Your homework for today and tomorrow, you will be graphing. These, I have the steps right here up on the board. If you've done the one from last week, you already know how to start it, where to go from there. I have all the steps written down for you here. You can go ahead and pause it, and you can go ahead and save it as a photo, so when you do your homework, you have it there available to you. So now we're going to talk about translating. Translating simply means it's from sine and cosine. You grab the original graph and you're shifting it left or right, or you're moving it up or down. So it's like taking a picture frame and moving it left or right, up and down. You're not changing, you're not making the picture frame bigger or smaller. It's just grabbing that frame and you're trying to move it wherever direction there. The period does kind of shift it just a tad, but we're just talking about moving it left or right and up and down from this point. Again, make sure to go back and look at the video if you haven't seen it for the sine and cosine. If you didn't, this will be confusing to you. Make sure you're always doing your work every day so then you understand what you're doing. Go ahead and look at this. And here it says y equals sine a b of x minus h plus k. What that means, to break it down, a is the amplitude, that's step one. B is considered your period, that means your wave, how many waves per one period. So here the period is 2 radians divided by b, so it's a number right after sine or cosine. So it's the same way, just the difference is sine and cosine. X minus h, what this means here is you're shifting the graph left or right. And step 4 here says if it's x minus theta, so it could be x minus radians, 2 radians, you're shifting it number of units to the right, and you're going to be adding radians to number 3, and I'll go through each one seeing what that means. And if you have x plus radians or theta, that just means given angle. So x plus radians, that literally means x minus negative radians, so it's actually a negative. Always think of opposite signs. You're going to be subtracting that to your 4 parts from step 3. And then you have your plus k in the end. You can have a minus k, you're shifting it up or down. So steps, find your amplitude, that's your minimum maximum point. You need one on the top and bottom. Find your period. You divide that into 4 parts, that's why I have all the way over there. You find your shift if there is any. For this, you're going to be adding or subtracting a theta for each one of these. And if you're shifting up or down, that's you're going to count it, and I'll show you later. And then graphing for the sine pattern, if you start at 0, you work your way up, 0, down, 0, up, 0. So it's always a pattern for that. Cosine, you start on the maximum point, so it's up 0, down 0, up 0, down 0. So they have a different way to it. You can't just rely on them all being the same. Example 1. Y equals sine of x minus radians over 2. If you don't like the radians, you can convert all of this into degrees. You can replace 180 in place of your radians. This is what you're supposed to keep. A lot of you gave it back to me. I don't know why. Here, let's say we have 2 radians over 3. If you do 2 times 180, so that's what radians is, divided by 3, you end up with 120. You can do that for any one of these over here. But the radians just means, you know, the number of degrees. 2 radians is 360 degrees. Let's go ahead and find our graph. So number 1, we find our amplitude. Amplitude is the a in front of, it's a number in front of sine. We don't have a number, we haven't understood 1. So that means the maximum point of 1, but then we have our minimum point of negative 1 as well. Period is 2 radians over b, so your b is a number in front of sine. You don't have one, it's just 1. 2 radians divided by 1 is just 2 radians there. 3, you're going to be dividing your period into 4 parts. That's going to show you your wave. Just like when you have x and y, you're trying to graph your line, you choose 3 different test values. Here you need 4 parts to a whole wave. So you do that. Whenever you're doing these type of problems, what will be easier is if you think of it as fractions. So think of 1/4 times 2. 1/4 times 2, I got radians over 2. And just include the radians in the end. So always include the radians on top. 1/2 of 2, so 1/2 times 2, you're just going to get radians. 3/4 times 2, you're going to end up with, just make sure I got this right, 3 radians over 2. And then 4/4, because you're dividing into 4 parts, it's just 1, which is just 1 times 2 radians, it's just 2 radians there. That means your whole graph, you're going to consist of graphing it based on these points here. Step 4, now we have a shift because of the, I think of parentheses, it's a horizontal shift. Whenever you have horizontal shift, you always have the parentheses like that. So you'll have it for a lot of these. You'll see example 2, you don't see the parentheses. Here, you shifted radians over 2 units. So we have x minus radians over 2. Always think of opposite signs. So x minus radians over 2, you're going to be adding radians over 2 units to each of your 4 parts here, because the graph is shifting radians over 2 units to the right. So here, I'll go ahead and use a different color. We're going to be going back to step 3, but we're going to be adding radians over 2. Whenever we graph, we always start at our origin here. So I'm going to put a 0 here because that's your origin here. You're going to be adding radians over 2 to every point there. So radians over 2 plus radians over 2 plus radians over 2. When you add that, so 0 plus radians over 2, instead of starting at 0, you're going to be starting at radians over 2 because you're shifting it to the right. Radians over 2 plus radians over 2, you get radians. Radians plus radians over 2, 1 plus 1/2, you get 3 over 2, so it's 3 radians over 2. 3 over 2 plus 1 over 2, think of 4 over 2, which is 2 radians. 2 plus 1/2, I get 5 radians over 2. And if you notice, these are all increments of 90, so 90, 180, 270, 360. So now we're starting at 90, 180, 270, 360, and just add 90 to the other one. I'm not going to do it. Now you have your new points right here. That's the points right there. Here, I wrote this down. You don't have to if you don't need to, but I have this down so I know it's a sine graph. You start at 0. This is a normal graph of a sine, so just y equals sine x. No shift, nothing. When I graph this, I'm going to start with my 0 here. So I always start at my 0, I always start at the origin, but now I shifted. So I shifted from here, and now if I look up here, I'm starting at radians over 2. So this is my first point. So 0 up, 0 down. So the next point, radians, I'm going to go up. Then 3 radians over 2, I'm going to go back to 0. 2 radians, I'm going down. 5 radians over 2, I'm going to go back to the 0 mark, and then I end up with a graph like that. It's terrible. But it's a graph like that, and if I keep on going, you don't have to keep on going. Your shift is, your wave is from radians over 2 to 5 radians over 2. Your period is 2 radians. If you were to add all of these, the number of steps that you've taken, that would equal 360, and that's one whole wave. So instead of the normal wave being from 0 to 2 radians, it's from radians over 2 to 5 radians over 2. I could keep on going with this, but this is like that. And that would be your graph. So it's the main portion right there where the green is. Next one. Y equals cosine of x plus radians. So right there. So first thing, find your amplitude. Your amplitude will be the number in front of cosine. We don't really have one. It's 1. Your period, 2 radians divided by the number in front of x. We don't have it this time, so it's over 1. So your period is 2 radians. You divide that radians into 4 parts. If you noticed, it's going to be just like this answer right here. So 1/4 of radians, 1/4 of 2 radians is radians over 2. 1/2 of 2 radians is just radians. 3/4 of 2 radians is 3 radians over 2. And 1 times 2 radians is just 2 radians. And that's your normal graph, the usual shift of it. But now, 4, we have to identify the shift. If you see here, it's x plus radians. Think of subtracting radians to each one. Remember, you always start at 0, so I'm going to include that 0 there. So I'm going to subtract radians from each one of these. When I do that, so 0 minus radians, negative radians. Radians over 2 minus radians, so 1/2 minus 1 is negative radians over 2. Radians minus radians, I get 0. 3 over 2 minus 1, I get radians over 2. 2 minus radians, I just get a radians. And these will now be my new points because I subtracted because of that shift that's going on with my graph. Here, it's a cosine. I wrote it down here for the pattern. It's up, 0, down, and 0. So it's going up and down. So here is a normal cosine graph. It typically looks like that, but now I'm going to change it a bit. It's shifting radians units to the left. That's what it means. So it's shifting this way. So now I start at negative radians. Negative radians is here. According to this, I go up 0, down 0. If you want to, you can do up, 0, down, 0, up. So then you won't get messed up. You're not starting at the origin anymore. You're starting at your new point, which is negative radians. So negative radians, I'm going up. And up means your amplitude. The amplitude is from 1 and negative 1. So up, negative radians over 2 is 0. 0, I'm going down. Radians over 2, I'm going back to 0. And then radians, I'm going up, which is right there. So your graph is going to consist of that. If I keep on going, it'll look like that. But my shift is from here to here, from negative radians to radians. That's one whole wave. And if you notice, the black one is the regular cosine graph, and it shifted this many units, so it looks different from your original graph. Third one, or example 2, we have vertical shifts. So the first two were horizontal, shifting left and right. Example 2 is just dealing with shifting up and down. So now, I'll deal with this here. So first thing, find your amplitude. Number in front of sign is 1, so amplitude is between 1 and negative 1. Your period is 2 radians divided by b. In this case here, in front of x is just number 1, so my period is going to be 2 radians divided by 1, 2 radians. Divide that into 4 parts. Again, just focus on a number. 1/4 times 2, you get radians over 2. 1/2 of 2, just radians. This is 3 radians over 2, and this is 2 radians. It's just the same ones from the other ones. And it's an increment. It's 90, 180, 270, 360. Number 4, if you see here, it's +2. There are no parentheses. When you don't see parentheses, it's an indication of shifting up or down. So it's a vertical shift. Here, it's shifting 2 units up. It's +2, so you're moving from the original source, so you're moving 2 units up. And for this, very easy. You have your points here, radians over 2. This is what the typical sine graph looks like. So I just drew the normal from the minimum, maximum, 1, negative 1. Here it does have an amplitude of 1, but now we're going to be shifting according to this. So here I'm going to go ahead and write 0. So that's a 0. I'm going to put 0 up, 0 down, 0. So I start at my origin, I always start at 0. But keep in mind, you're always shifting 2 units up from every point. So if it was originally over here, I'm moving 2 units up, my new point will be here. At radius over 2, I'm going up. Normally my maximum point is 1, that's my amplitude. I would have to graph here 1, but now we're shifting every unit 2 units upward. So that means my new point is up there. Radians, I would normally go back down to 0 to the origin, but now we have to go 2 units upward. So that's going to be up here. Radians 3 over 2, we go downward. So 3 over 2, we go back down. So down, the minimum point is negative 1. Remember, it's your amplitude, 1 and negative 1. So at negative 1, I'm going to go down here. But then keep in mind, we have to move 2 units upward. So this is negative 1, 1 unit, 2 units, which is down here. And then back down to 0. So here I didn't put all 5 of them, but I'm just going to, I know it's a pattern, so it's the same thing. So at 0, 2 radians, I'm going to go at 0, but then I have to count 2 units upward, which is like this. And when I graph it, I end up with a graph that looks something like that. So shifted upward 2 units. Last one we have is y equals cosine minus 1. If you look here, no parentheses, you're moving 1 unit down. It's a negative, down, positive, up. Amplitude, number in front of cosine, is 1. So your maximum is 1, minimum is negative 1. Your period is 2 radians divided by the number in front of x. It's just 1, which is 2 radians. Divide that into 4 parts. Again, excuse me, it's a pattern. So it's radians over 2 radians, 3 radians over 2, which is 270, and this is 360. 2 radians. And the last part is we're going to go ahead and graph. We noticed and we indicated that we're going to be moving 1 unit down. I graphed here the original cosine graph. So this is a normal cosine wave. This is what it typically looks like. From each point of these here, I'm going to start at 0. I'm going to go ahead and follow it, and now I'm going to move 1 unit down instead of 2 units upward. So I'm going to put 0 here. I know that for cosines, I start at my maximum point. I start up. So 0 and put up, 0, down, 0, and back up. So that's my wave of the graph. So at 0, I'm moving upward. If I notice here, this will be my point, but now from every point there, I have to move 1 unit down. So now my new point will be here. Radians over 2, I always go back at the origin here. So that means I would have my dot here, but now, if I remember, every unit is being shifted 1 unit down. So that's my unit, new one right here, new unit. Radians, I'm going down. So I'm going to go my minimum point, which is -1 here. But keep in mind, I have to move 1 unit down. So that will be my new one. 3 radians over 2 back at the origin or back at 0. But keep in mind, we have to move 1 unit down, which is down here. And then last one is 2 radians, and that's up. We have to move 1 unit down, and then we have that. So when I have my graph, I have something like that. And that would be my last graph. So the first 2 examples just consist of the shifting left and right and up and down. And tomorrow we're going to deal with the whole thing all together. If you have any more questions, let me know. If you need to, remember to go back to the video if you want to ask me which video it was. You have it on your book, but I can refer you. Just message me, email me. I can let you know. Bye-bye.